Hello, everyone. Now we are witnessing the major two events unfolding across the world. One major change is the rise of AI, and it has huge impacts on society and energy. And the other major event unfolding is the Hormuz Strait crisis that also has huge impacts on everything, but on energy, of course. And given these two backgrounds, we have to seriously reconsider the energy policy of Japan. Today, we with the Ted Nordhaus, who is the chairman and the founder of the Breakthrough Institute. Welcome, Ted.
Thank you.
And could you just begin with the introducing yourself and the Breakthrough Institute?
Yes. So I am actually the president now and the founder of the Breakthrough Institute. And I started Breakthrough about 20 years ago. Started a new kind of environmentalism that was pro-economic growth, pro-development, and pro-technology. And so the Breakthrough Institute focuses on technological solutions to environmental problems and understands that environmental issues must be understood in the broader context of human development. And so we believe that you can't solve environmental problems if you aren't first taking care of human needs and allowing humans to live sort of materially rich and abundant lives.
Okay, then let's begin with the nuclear issues, because the nuclear is one of the technologies that bring about prosperity and environmental solutions, in my understanding too. And we understand that there's been a major development with regard to nuclear technologies in the U.S. in recent years. And could you elaborate on it?
Yes. We launched the global pro-nuclear movement about 15 years ago. Took a long time to change public opinion, but public opinion has changed a lot in the United States as well as many other places, I believe, as here in Japan as well, with people realizing that nuclear energy is both very important to abundant, reliable energy to power the human future, and is also a critical environmental technology. So in the United States, as that shift has taken place, there's been increasing efforts to relaunch a globally competitive 21st century nuclear industry. A lot of that effort has been focused on next generation advanced nuclear energy. And that effort and policies have been sort of slowly moving forward over the last 10 years or so. But in the last several years, it has really been accelerated. And it's been accelerated for a couple of different reasons. The first is just general concern with high energy prices, domestically and high electricity prices, and recognizing that even with very abundant natural gas, and even if the U.S. is buying lots of Chinese wind and solar and batteries, you need sort of firm, low-carbon nuclear energy if you're over the long term going to have a very low-cost grid that can grow to meet future demand. And that then has been really accelerated by the very, very rapid expansion of AI electricity demand. So the big hyperscalers, Google, Meta, Amazon, Microsoft, are all looking for nuclear to power their data center needs in the future. And in the short term, that has involved sort of restarting nuclear plants. So Microsoft now has a deal to reopen the 3 Mile Island plant, a very symbolic move. The hyperscalers are sort of doing direct deals to buy energy from existing nuclear power plants. But then they're also making very significant commitments to next generation nuclear that should start coming online in the early 2030s. And this has really changed the economic picture for nuclear. I think the economic prospects and the economic conditions for scaling up new nuclear in the United States are probably better than they've ever been right now, because these data centers are willing to pay a premium substantially above market rates to get firm, reliable, dedicated, low-carbon power to power data centers. And really, sort of, certainly in theory, and we'll find out in the next decade or so whether that is true in practice, there's almost nothing better for scaling data centers than small modular nuclear reactors. And so all of the sort of most promising, what people sometimes call Gen 4 nuclear reactors, Bill Gates' company TerraPower, X-Energy, Kairos, Oklo, are all now have sort of quite substantial deals with different hyperscalers where we're talking multiple gigawatts for each of these reactors. And these are small reactors. So each of these reactors will be, between 50 and 400 megawatts of electric power. So when you talk about, say, Amazon committing to 5 gigawatts of electricity from X-Energy, which is a 150 megawatt reactor, that is, 30 units. So you start to see an order book. It starts to look like, the way when Boeing or Airbus launches a new jet, they usually launch it with hundreds of orders so that they can spread the development costs across and the manufacturing capabilities that they have to develop and the supply chains across many, many units. Well, the small modular reactor orders from hyperscalers are starting to look like that, and that has the potential to be quite game-changing, not only for nuclear in the United States, but nuclear globally.
Great. And is the government also assisting all those development through modifying regulations or subsidizing the pilot phase or something?
Yes, the Trump administration executive orders, which came out early last year, have been quite transformative for nuclear regulation. So the Nuclear Regulatory Commission has quite dramatically streamlined its regulatory processes and really focused on making licensing and other regulatory decisions much faster, which is really critical for any new reactor developer trying to get a commercial design to market right now. TerraPower, its construction permit was issued well ahead of schedule, and I think we're sort of starting to see these licensing determinations moving through the queue much faster. The regulator, really focusing on safety critical issues and not trying to regulate every screw and bolt and piece of rebar in the entire facility, whether or not it's safety critical or not. And then the other thing that the administration has done is it's created a demonstration reactor pilot program at the Idaho National Laboratory. I think it made awards or grants to 10 or 11 micro reactor vendors, very small reactors. And the first probably half dozen of those will demonstrate criticality at Idaho National Laboratory. And these are not science projects. These are commercial reactor companies this year, many of them this summer. So we've just really kind of rapidly accelerated the metabolism of reactor development and innovation and commercialization from anything that we've seen, really in the United States or globally for many, many decades. And that's what happens when you have an administration that is not half in, half out on nuclear, or the Biden administration sort of saw it as a box to check as part of its climate strategy, but didn't really see it as a national imperative. And particularly because of the sort of geopolitical and economic dimensions of the AI race with China and other global powers, the Trump administration really sees nuclear as a national security priority and imperative. And it shows in terms of the policies. So in addition to these pilot programs, the companies that actually sort of demonstrate viable reactor technologies will very quickly get significant contracts from the Department of Defense to provide small nuclear power plants to power military bases domestically in the United States. So there's a procurement element that is going to kind of create a lot of the produce a lot of the kind of market conditions to very rapidly accelerate commercialization of a whole set of these reactor technologies. And again, because they're small, they look more like gas turbines or wind turbines or jet, commercial aircraft, as opposed to what nuclear has historically been, which have been very, very, these mega public works projects. And so you get potentially much faster technological learning because you're manufacturing most or all of the reactor in an actual manufacturing facility or on an assembly line. And when you put that together with the fact that because they're smaller, these very large orders coming from hyperscalers and the Department of Defense mean that you're producing many units, you're able to get much more rapid technological learning and sort of process innovation in producing these reactors. I think at least the hope is that really sort of accelerates these reactors coming down a cost curve so they can get much cheaper, much faster than the sort of legacy large reactors, where if you did it really, really well, as sort of China is doing now or Korea is doing now, you can do them fairly cheaply, but you're not going to sort of see, you're mostly keeping costs stable, as opposed to seeing really the kind of cost reductions that we've seen in other energy technologies like solar or natural gas turbines, where because they're fully manufactured products, you can actually really kind of over a period of innovation cycles see the cost of those technologies come down quite quickly.
Okay, great. Sounds like a very exciting development in America, and I think that the rest of the world, including Japan, will be benefited from all those. And let me talk a bit about the Japanese energy crisis situation. I would say now that Strait of Hormuz is, I would say, virtually closed as of today, and almost no shipping of oil and natural gas from the Middle East Strait of Hormuz at this moment. That is about 10% of the global oil and gas supply. And Japanese have been dependent heavily on the Middle East oil. We import almost all fossil fuels from the rest of the world, and then our dependence on the Middle East was 95% in last year, and our dependence on the Strait Hormuz was also about 95% last year. So now we are in scramble mode. We have, fortunately, 250 days or something more stockpiles. So we are now using stockpiles to meet the oil demand. But it's going to run out someday if the closure continues. And it's not likely that Strait of Hormuz will come back to the original state anytime soon. It's my view that oil supply will be unstable or scarce in coming several years, and at least we have to prepare for that. So the government is now crazy for the government is now enthusiastic to gather oil from the rest of the world or alternative pathway than Strait of Hormuz. But in addition to that, I think it's my belief that we have to rely more on coal because if we look at our power sector, then the composition is as follows. The natural gas fire power plants provide 1/3 of Japanese electricity, and coal provides 1/3 of Japanese electricity. And nuclear is just several percent at this moment. So of course we have to restart the nuclear, but it will take time. And meanwhile, the natural gas price doubled before the Hormuz Strait crisis compared to the time before the Hormuz Strait crisis. And 10% of natural gas supply is lost by the Hormuz Strait crisis. So it does make sense for us to have more coal fire power in short term. It can be done easily by just using existing capacity with more capacity factor. And for the time being, for coming several years, I think it's also important to keep our coal fleet, at least. The Japanese governmental priority so far has been the decarbonization, so-called. And so there's a lot of regulations and surcharges and many systems that penalize coal-fired power plants, basically, so that the government expects that the fleet of coal power will be decreasing in coming decades. But I think it has to be stopped for the time being to supply secure and cheap electricity for Japan. So for the time being, it's my belief that coal should be should remain as one of the pillars of energy supply in Japan. But in the long run, what I would like to see is to have more nuclear facilities out of the security reason in the first place and economic reason for the second place. But if you really want to cut CO2 down, then it looks like in the long run, it is the most promising way, because that if you try to reduce CO2 via too much renewables, intermittent ones, then it will cost a lot, and so there will be no public support. But if we take a pathway from coal to nuclear, then I think that the electric price can be kept low, and we are ready for international turmoil, and so there will be more public support. And then in the end, we will have a stable and cheap and less CO2 systems in the end. That's my view, but I would like your reflection.
Yeah, I think it's one of the things that we see around the world is that if you have a lot of cheap natural gas, decarbonizing your electricity sector is fairly easy to do up to a point, because the gas can replace coal, and that cuts the CO2 intensity of that generation by about half. And gas is also a very good fuel, fossil fuel, to provide sort of firming, backup, sort of generation to follow variable generation, wind and solar. So you can then add lots of wind and solar, which is sort of cheap, can be cheap on the margin, as long as you have a lot of natural gas capacity to ramp up and down to make sure that you keep the lights on. So the natural gas replaces coal, and then the solar and wind are essentially fuel-saving technologies on the margin of your electricity system. And that can work fairly well for a period of time until you start to see high penetrations of solar and wind, at which point you have a very large natural gas generation capacity with very low utilization, which starts to get quite expensive. The other problem and the other thing when that becomes a problem is what we're seeing today in Japan and a lot of other places, which is that that decarbonization strategy is not a very good one when gas becomes very expensive.
Right.
For Japan in the short term, it has still a lot, because of the sort of increase in gas use and, primarily gas because wind and solar are still a very small part of Japan's generation mix. You have a lot of coal capacity that is also pretty low utilized. So in the short term, one way that you get through a crisis like this is just to run your coal plants more, which will have a short-term emissions impact. But you're also not building new coal plants. You're just using your existing plants more. The second thing you can do is try to accelerate restarting your nuclear facilities because there's very substantial nuclear generation built nuclear, and that's a remarkable asset for Japan to have, which it has sort of in the wake of the Fukushima accident. It chose for a period of time not to operate. But I think, as you said, I think public opinion and the sort of geopolitical and economic situation very clearly dictate that Japan should be restarting its nuclear plants as rapidly as it possibly can. Then you get to the sort of longer term picture. And for Japan, because you don't have significant domestic fossil fuel endowments, and you actually really don't have great wind and solar resources, and even insofar as you do, the extraordinary advantage that China has in those technologies means that Japan is really sort of faced with two not very appealing geopolitical choices. One is to continue to have its economy be at the mercy of imported fossil fuels from the Gulf, from the United States, from various other parts of the world. Even coal would have to be imported from Australia or the United States or Indonesia. Or the alternative that many people put out there is to sort of basically become very dependent on Chinese sort of green technology. So if you're, in Japan's situation, neither of those is a particularly attractive. In the U.S. we would call that a Hobson's choice, a bad choice. But the thing that Japan does have, it has a significant already existing nuclear capability. It has domestic nuclear technologies and firms and suppliers of components. Japan is one of the few places in the world, for instance, that you can go and find facilities that can build, that can forge reactor vessels for large reactors. It has very, very significant technological knowledge and capabilities, supply chains. There's really no reason that if Japan decided to, it couldn't significantly and fairly rapidly build out a lot of new nuclear capability, which would allow it to not have to choose between imported fossil fuels or imported Chinese green energy technologies. So in a lot of ways, coal may be a short-term strategy. Nuclear for Japan in terms of sort of energy security probably is almost certainly the best technology for Japan long-term to assure its long-term energy security.
Can we elaborate a little bit about coal to nuclear concept? I once read a report commissioned by DOE, I think, talking about the concept coal to nuclear on global scale and an American scale, I think. And the basic idea is that to replace coal from coal to nuclear on site-by-site base, because there is an existing infrastructure already that supported coal can be simply used for a new nuclear reactor, because if you simply replace the reactor from coal to, we wouldn't call it reactor in the case of coal, but we can replace boiler by a reactor of the nuclear, then the rest infrastructure can be used so you can save certain money, and there are many other benefits. And can you add something on that?
Yes. So, when we think about sort of coal to nuclear, it's, there's a context here, which is if you look at the long-term trajectory of global energy systems, they've tended to move from more carbon-intensive to less carbon-intensive technology for both in terms of fuels. So you go from coal to natural gas. Every molecule that's combusted and every unit of thermal energy that is released through that is about half as carbon intensive, because you're looking at a molecule, the methane that you're combusting in natural gas turbine, for instance, is 1 carbon molecule and 4 hydrogen molecules, CH4, whereas coal, the coal molecule is a much more carbon intensive. There's a lot more carbon in that molecule that gets combusted, and so gas is a cleaner, more efficient source of carbon-based fuel. And then obviously you start to move from natural gas to nuclear, or as we've seen in a lot of places, natural gas being partially replaced by renewable energy. But in all of these processes, you're moving from more carbon-intensive energy generation to less carbon-intensive as you become more technologically advanced. And a lot of people in that context, there's a very famous idea of sort of going from natural gas to nuclear. But there's no reason, in many cases, you can't go directly from coal to nuclear. There's not a necessary intermediate step to natural gas. If you look at, for instance, what China is doing, if you look at the coal plants, the new coal plants, very efficient modern coal plants that China has been deploying to generate electricity around the country over the last decade or so, those plants are literally pre-designed to be able to replace a coal boiler by dropping in a high temperature gas reactor. And China is now beginning to commercialize its first smaller high temperature gas reactors. And there are a range of use cases for those reactors, but one of them is literally you have a built coal plant and you will just literally lift the coal boiler out and drop this high temperature gas reactor in, and the sizing and the dimensions and the engineering of that plant, that's an intentional design to be able to enable that. More complicated in the U.S., the study you referenced was looking at both existing and also a lot of retired coal generation sites, because in the U.S., especially in the wake of the shale gas revolution, we've retired a huge amount of coal generation. We're not just running the plants less, but we're really fully retiring these plants. But those plants have a lot of infrastructure that can be reused by nuclear plants. So you can
transmission lines,
things like
transformers,
and now and I think a lot of people, one of the things people think this will be like China, where you'll just have the old coal facility and you'll drop a new nuclear plant in, and that's actually mostly not how this is going to work. But most of those plants have fairly large, they're called brownfield sites because they've been used for energy generation and industrial activities for many decades in most cases. But there's a fair amount of open land there where you can, so you're not going to like literally use the old coal plant. Usually that will be torn down or just left. But then they will, there's ample land in those sites that's very proximate to transmission, transformers, often water supplies if it's going to be a water-based reactor that can be reused for nuclear energy. So, and nuclear, has a lot of very similar attributes to coal. In the electricity system, it's a very good technology for providing, very large amounts of baseload power. So it has it's well suited to having a very similar generation profile to coal and playing the same role on an electrical grid. Depending on the reactor type, the conventional large light water reactors tend to run at significantly lower temperatures than coal, so they're not as well suited for providing process heat for industrial processes, refining, things like that. But these new high temperature gas reactors are. So for instance, the first X-energy gas cooled high temperature reactor is not going to be, even though they've got a big deal with Amazon to power data centers, their first reactors will be deployed behind the fence at an existing Dow chemical facility to replace I'm not sure if it's coal or natural gas or a combination of coal or natural gas that has been used at that facility. But the first 4 X-energy high temperature reactors will actually be powering, be used for refining by Dow Chemical on the Gulf Coast of Texas. So there's a range of uses where, nuclear, particularly next generation nuclear, can replace both coal and natural gas for non-electricity industrial applications as well.
Sounds good. Okay, today we invited Mr. Ted Nordhaus, and we listened to their talk about nuclear development, and we also have elaborated the possible strategy for Japan to secure energy security and economy that is from coal to nuclear. Ted, thank you for coming, and we enjoyed talking with you.
Thank you. Great to be here.